I'm just checking why this not working, man. Look at this. It's 1 minute video just cut off right now. I was trying to show that I already did 40 minutes of streaming and I was learning, but this is game. Let's make this private also. Mm, yeah, these two are private now, and I did the live stream. Okay, I was doing this and reading and gone. Given interval, so please be connected again. OBS Studio, man, damn. Oh, this was being shown. It's okay. Connected again. From meter, from from iterable. Okay, from iter. This is an built-in num. Yeah, it's connected again. Yeah, when that tidding sound. Please be connected again. Yes, no. There's connection error right there. What the... It's so fluctuating, man. It's around 5,000 and then 7,000, 5,000, 7,000. There's no... This obvious, man. Sometimes. I guess the firewall was the problem. Okay. Bro, this didn't even connect. I was just... It was around 2 minutes. I was showing this whole of a shit and it didn't even show that. Never mind. We'll start reading again. I guess I'll just type for some time. Let's do this. I'll type. What will I type? Yeah, it's so fluctuating. Okay. I can look at the bitrate, right? It's 6,000, then around 58, then 59, then again 6,000. I have set it for around 6,000, I guess. That's 6,000. But it's not working. I gave it even the firewall connection problem. Don't know what's happening. मंजिल तक जाऊं बस तेरा साथ तेरे बिना हो चैन मुझे रात सो आखिर हो गया है मुझे ये एहसास हूँ माजी में फंसा हुआ करूँ मैं प्यार जब हम गुम थे जब हम सुनते कैसे थे वो नाते छुपी छुपी आहटों की गहरी मुलाकातें वो दिन जब साथ थे दिन यूं ही ऐसे मुस्कुरा के बिन रोए गुजरते रहे वो दिन दिल हुए नरम से कसम में रहे ये दिल तो रहता ये खुश है वो तू किधर है आजा पास ना तन्हा लगे वो तू किधर है जरा बोलना दूरी छोड़ी बात तू किधर है किया वादा के ना छोड़ेगी तू साथ तू किधर है तू किधर है tu chiedere oderi che mi care passano sei
Well, you only need the light when it's burning low. Only miss the sun when it starts to snow. Only know you love her when you let it go. Only know you've been high when you feel low. Only hate the road when you're missing home. Only know you love her when you let her go.
And let it go.
And you let her go.
But
Staring at the boats and multi-class, hoping one day you'll make your dream last. Dreams come slow and go so fast. You see you when you close your eyes. Maybe you one day you'll understand why everything you touch surely dies. But you only need the light when it's burning low. Only miss the sun when it starts to snow. Only know you love her when you let it go. Only know you've been high when you're feeling low. Only hit the road when you're missing home. Only know you love her when you let it go. Staring at the ceiling in the dark. Same old empty feeling in your heart. 'Cause love comes slow and it goes so fast. When you see you when you fall asleep, but never to touch and never to keep, 'cause you loved it too much and died.
what is this spinning, man?
When you only need the light when it's burning low. Only miss the sun when it starts to snow. Only know you love her when you let her go. Only know you've been high when you're feeling low. Only hit the road when you're missing home. Only know you love her when you let her go. And you let her go. Then you let her go. When you let her go. When you only need the light when it's burning low. Only miss the sun when it starts to snow. Only know you love her when you let her go. Only know you've been high when you're feeling low. Only hate the
What
road when
is
you're
this?
missing home. Only
Damn,
know you love her when you let her go.
what a bad 61.
When you only need the light when it's burning low. Only miss the sun when it starts to snow. Only
WNEMY.
know you love her when you let her go.
Okay, now it's stable, I guess.
Only know.
Let it be stable. I don't want to deal with this, and I'll start reading. Otherwise, I'll just end the stream. I'll just read it. I'll tell you tomorrow I read it. That's it. That's how it works. So let's start again. Yeah, we were in lean space, right? And we talked about norm 15, numpy lean space, start, stop, in point 2, rest, pause, non to enumerate. This function returns evenly spaced numbers over a specified between two limits. Okay, 3.5, 10, 3. So 3, 10. Now 50 input true. We will create an array from 3 to 6 in 3, 3. It should be 9, right? Okay, this function create a new array of given shape and type without initializing values. So dot empty shape, uh, that shape is 483 as well. So there's garbage value here, 0 0 empty. So order F. It's 4 by 3 1 2 3 1 2 3 4 1 2 3. Okay, and the output will be randomly generated array. Okay. Numpy dot once. Now the sun is right at my head, so it's hard for me to read if sun is right in my face. And this function is used to get a new array of given shape and type filled with ones. Numpy dot once shape d type num order c. Why? The function is used to get a new array. I was so good. Like the sleep was so good today, but it's winter, right? And if there's sun, then I'll get sleepy. This sun is so good to give me sleep. This function is used to get a new array. Numpy at once, shape, non-order, dtype, array. This function is used to get a new array of given shape and type filled with zeros. So numpy 1 shape. That's done. Oh, it's so small. Arithmetic operations and array broadcasting. It's also like arithmetic operations are used for numerical computation, and we can perform them on arrays using numpy. With numpy we can quickly add, subtract, multiply, divide, and get power of elements in an array. Numpy performs these operations even with a large amount of data. In this article we'll see at the basic arithmetic functions in numpy and show how to use them for simple calculations. Addition of arrays. Addition is an arithmetic operation where the corresponding elements of two arrays are added together. In NumPy, the addition of two arrays is done using np.add function. You can just what if you do A plus B? What if you do that? Easy. No need to do that np.add, right? No need to do that. Just add subtraction. A minus B and p dot subtract. Damn. This function subtracts each element of second array from corresponding element in first array. Multiplication of arrays. Multiplication in NumPy can be done element-wise using the NP multiplier function. This multiplies corresponding elements of two arrays. Import NumPy as NP arrays multiply. Da 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 da. Down, 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 down. It works. It works, bro. It works. If it works, no need to do. Uh, well, thanks for NumPy developers. NumPy function. Division of arrays. Is important. Other another important operation that performs element-wise. The NP divide function. This divides each element of first array by corresponding element in second array. Should work. Yeah, it should work. It should work. It works. NP divide. Okay. Exponential power. It allows us to raise each element in array to a specified power. NumPy. This can be done using the NP power function. NP power. NP power. NP power. NP power. NP power. NP power. Yay! Done. Modulus operation. It finds the remainder when one number is divided by another. In NumPy, you can use np.mod function to calculate the modulus element-wise or between two arrays. So this is okay. So mode is okay. Mode is good. Mode is better. Mode is very very better. Modulus should work. 1 2 3 10. 1 2 3 10. It works, guys. Okay. Broadcasting. NumPy array broadcasting. No, broadcasting in and NumPy allows us to perform arithmetic operations on arrays of different shapes without reshaping them. Okay, so allows us to perform arithmetic operation on arrays of different shape without reshaping them. Okay, broadcasting lets us do that. It automatically adjusts the smaller array to match the larger array shape by replicating its value along the necessary dimensions. This makes element-wise operation more efficient by reducing memory uses and eliminating the need for loops. Okay, let's see an example. Let's say an example, import numpy that np array two arrays of two dimension, one array of two dimension a and x is chain. So uh, num expands the scalar x to match the shape of array a. The operation adds chain to each element of a. Okay, that's correct. That's done. Working of broadcasting in numpy. Broadcasting applies specific rules to find whether two arrays can be aligned for operations or not that are for operation or not that are check dimensions. Ensure the arrays have the same number of dimensions or expandable dimensions. Dimension padding. If arrays have different number of dimensions, the smaller array is left padded with ones. So shape compatibility, two dimensions are compatible if they are equal or one them is one. If these conditions aren't met, NumPy will raise an value error. Let's see various examples for broadcasting below. Example 1. Broadcasting a scalar to a 1D array. It creates a NumPy array ARR with values 1, 2, 3 and adds a scalar value 1 to each element of the array using broadcasting. So it adds value to array 2, 3, 4. Broadcasting a 1D array to 2D array. Okay, it expands 2, 4, 6, and it adds uh, 1, 2, 3, 7, 11, 2, 9, 13, 17. Okay, explanation. A1 has shape 3 and has shape 2, comma 3. By automatically repeats. A1 has shape 3, A1 has shape 1. Oh, it's called shape and comma. Oh, it should be 1, right? 1 and 3. 1 comma 3. Should be 1 comma 3, right? Let me see, let me see. Let us print, right? And A dot shape. Uh, should give the answer, right? Callable. Wait. NP shape or shape? How is it called? Ow, ow. Ow. What if I do B? Will it work on B? Should work. No, it's not working. How is it because of tuple? No, it's an array. NP dot shape. NP dot shape. NP dot shape. B. Okay. Sorry. I thought it's a method. 3, comma. Oh, it is like that. Oh, okay. Okay. It's 3 and comma. Okay, got it. 2 and 3. It's 3 and comma. And if I do, what if I do what type of video am I going to do? Okay, never mind. It works then. It's 3 comma. Okay. NumPy automatically repeats A1 across both rows of A2, so the shape matches. Then it adds element position wise. So it adds here, it adds here. Okay, broadcasting in conditional operations. This example checks each age in array and assigns adult or minor using np where. Uh, if it's greater than 18, it's B0, that is adult. If less than 18, then B1, that is minor. Okay, and it checks for every single element here. Okay, and it gives another conditional. Yes, creates a boolean array by checking every value at once. String. In this example, each element of 2D matrix is multiplied by corresponding element in a broadcasted vector. Explanation: the vector V is broadcast across its row of M. Multiplication happens element-wise without loops. Result is a scaled version of the matrix. Scaling data with broadcasting. Consider a real-world scenario where to calculate the total calories in foods based on the amount of fat, proteins, and carbohydrates. Each nutrient has a specific calorie value per gram. Fats 9 calories per gram. Protein 4 calories per gram. Carbohydrate 4 calories per gram. Food fats, protein, carbs. Food fats, protein, carbs. apples and 4. Uh, mm, what it added? What didn't add? What did it do? Scaling. So it multiplied. Hmm. Using this one, it can't multiply. It is multiplying this and this. Okay. It should be 1 by 2. 1 by 2, right? 2, 10, 20. And 2 by 2, 2, 1, 2, 3, 4. So multiplying. 2 rows, 1 column. 2 into 1. It should be 2 into 1. And 2 into 2, 2 to 1, and 2 into 1 will be answer. That will be Doesn't that how matrix work? 10 and 40, but 10 and 40 again it adds, right? 10 and 20, 30 and 80. That's correct, but this should be addition between these two values, right? And these two values. No. Then if it's 3 into 3, but it's multiplying like that. I get it. But it's not doing matrix multiplication. It's doing matrix multiplication, but there's no addition between the elements, right? It's not exactly right. Matrix multiplication. Let table shows the original data with food items and their respective grams of fat, protein, and carbs. The array 944 represents the calorie value per gram for fat. 944 calorie value per gram. So this array is being broadcast to match the dimension of the original data, and arrow indicates the broadcasting operation. So it's 944. Why is this 338? Broadcasting array is multiplied element wise with each row of the data, original data. Array is multiplied element wise with each row. As a result, right table shows the result of the multiplication where each cell represents the caloric contribution of that specific nutrient in the food item. So it's 944, then it's like this. So what? 3, 3, 8. Run, brother, run. It should be like this. Yeah, 2.4, 157, 43, 33, 9.2. Yeah, this is correct. And this is just multiplying in each row. So multiplying each row. Hmm. Each row, yeah. Broadcast upon each row. Each nutrient gram is multiplied by its calorie value. Result is a matrix showing calorie contribution from fat, proteins, and carbs for each food item, adjusting temperature and data across multiple locations. Suppose you have a 2D array representing daily temperature and reading across multiple cities, and you want to apply a correlation factor. Cities temperature data correlation factor. This is slicing, and this is all core app input array temp and add it. Okay, two eyes. You can see me. Turns the 1D array into a column vector. Turns the 1D array to a column vector. Print let's run this. Oh, sorry, it was never closed. Oh, sorry about that. Thank you for. Yeah, look at this. It changes it into column and addition. Added. How is it added to temp? Oh, it's added like this. This. 2, 4, 26, 25, 23. Oh, oh. Genius. Vector down each root of temp, each city temperature gets adjusted using its corresponding correlation factor, normalizing image data. Normalization is important in real world scenarios like image processing and image learning because it centers data by subtracting the mean by ensuring features have zero mean, scales data by dividing by the standard deviation by ensuring features have unit variance, improves numerical stability and performance by algorithms like gradient descent. Okay. X is 0, X is 0, yes. So this M and S are 1D array mean and standard for each column, and to broadcast them all rows of image centers the data dividing by scale it by S scales it giving the normalized values. Kokore. Oh my head is okay. Tutti okay. Done. Centering data in machine learning. Centering data is an important step in many machine learning workflows. Broadcasting helps center the data efficiently by subtracting the mean. Centering data is an important step in many machine learning workflows. Broadcasting helps center the data by efficiently by subtracting the mean from each feature. This example centers each feature by subtracting its mean using NumPy broadcasting. NP array data.mean access minus m this. Okay, explanation. M is an 1D array containing the mean of each column. Yup. And P broadcast M across all rows. NumPy all rows subtracting its centers every feature around 0. Na, 15 and 25. Okay, 15 and 25. Okay, read. Done. Oh, sorry about that. Okay, we'll be doing. We'll be doing. What is this quiz, man? Which of these are valid 2D numpy array? Okay, this should be valid. Yup. What does nd array dot shape return? Number of elements, name of array, size of array. Oh, yeah, number of elements, dimension of array, rows and columns, size of array, name of array. This should be it. How do you find the total number of elements in an array? Total number of elements, count, array length, size, should be count, should be length, total number of elements, length or count, length or count, length or count, or count. What? So this gives the total number of elements in array. Uh-huh. Didn't know that. Which method returns the number of dimensions of an array? Number of dimensions. Dimension? Number of dimension? Is that it? Should be it. Don't know. What can I do?
अनि सुन न त्यो लैजान पकाउन लैजानुपर्छ एउटा गोली हो राम्ररी
Don't know what to do.
अनि एउटा राम्ररी बोले जम्दा
What it is.
जम्दा र स्कुलमै गर्नु अनि अनि गाडी के गर्ने ठुलो
I'm back. Should be shape, right? Returns the number of dimensions of an array. Method. It is telling about method. Is this a method? It should be bracket, right? That's a. Why did I choose this? Is because number of dimension n and d, right? Shape will not be like that. This 5-1 is also like that. What is the output of A0 if A R is equals to NP R is 10, 20, 30? In an array, a 2D array, what does ARR10 give? First element of second row, second element of second row, first element of first row, last element of last row. It should be second element. It should be first element of second row. Yes. How do you access the last element of an 1D array? -1. Easy. What does np.add return? Which function multiplies two array element wise? Multiplies, right? What will happen? What will return? What is broadcasting in a numpy? Creating videos from array. Printing large arrays. Sorting arrays. Stretching arrays with smaller shapes to perform operations. Which of the following is valid broadcasting? Which one of the following is valid broadcasting? Both B and C. One B and C. B and C. B and C. B and C.